Assalamualaikum. My name is Amshad Fauzal bin Muhammad Noor, and my team and I from Group 4 will present about static assignment set 4. And my part is question 1. So the so the question asks to determine the force in each of the members of the trust show. That means from the question give the figure to state whether each member is in tension or compression. To answer this question, we have two methods. The first one is method of section, and the second one is method of join. So to begin, firstly we use method of section at point I, G, E, and H. So in static, we learn there are three formulas. First one is sum of Fy direction, sum of Fs direction, and another one is moment equation. Moment formula. That means moment is equals to force times distance, and distance must be perpendicular direction from the force direction. So we assume the counterclockwise is positive. So sum of moment around point I is equal to 0. So we got 10 kilonewton times 3. 3 is distance, is the perpendicular distance, plus 10 times 6, plus force point E to point F times 6 is equals to 0. Why? Force from point E to F must be times 6 because the perpendicular distance from FEF is 6. So that's why we put 6 at this equation. So we conclude that force EF is negative 50 kilonewton and it is a negative value. So that means it is compression force. If the answer got negative value, it is compression, and if the answer got positive value, it is tension. So we continue this calculation. We also assume that counterclockwise is positive value. So sum of moment around point E is equals to 0. So force E to C times 2.5 minus 10. We put minus and positive because from force E to C is counterclockwise around the point E. So that's why it's positive, and 10 kilonewton is a clockwise around the point E. So that's why it's minus. And minus 10 times 6 equals to 0. So we got FEC equals to 36 kilonewton and is positive value. So we know that positive value is tension. So using another formula, sum of Fy direction, we assume if force going up, if force going upward, it is a positive value. So sum of Fy direction is equals to 0. So we got around the section that we draw at free body diagram, we got minus 10 times 3 times 3 because they have 10 kilonewton minus FEF and minus FHF times 5 over 30. How we got 5 over 30? We refer at the figure that question show the total vertical is 5 meter and the total horizontal distance is 3 times 4. It is 12 meters. So at the point FHF is a hypotenuse. So that means we have to find the hypotenuse distance. So after we conclude, after we made a calculation using by trigonometry method, we got the hypotenuse of this truss is 12, is 30. So because it is y direction, it's going up and going down, and also point F is at the down from the point H. That's why we use cosinus angle from point H. So if cos theta equals to 5 over 30, so equals to 0. So we substitute the result of FEF that we got from the calculation this calculation to the calculation that we do it right now. So it is force EF is negative 50, and we got after doing this calculation, we got FHF equals to 39 kilonewton and it is positive value. That means it's tension force. So we move to the next part. We draw FBD diagram at point I, C, D. I, C, F, D by using the method of section. So we know the total horizontal distance is 5, and point F, we know that the total vertical distance is 5. So we know from the figure that question shows F is the center of vertical line. So that means 5 over 2 is 2.5. And we also know that from this truss, they have 4 parts. That means if we 5 over 4, that means 1 part is equals to 1.25 meters. So if point C to D, the vertical values is 2.5 plus 1.25. So that means the total vertical values at the point C to D is 3.75. So we continue the calculation. we assume the counterclockwise is positive and the moment around point I is equals to 0. So 10 times 3 plus 10 times 6 plus 10 times 9 plus force CD times 9 is equals to 0. And we got FCD is equals to negative 20 kilonewton and its negative value. So that means it's compression. And we move to and we use to another formula at y direction. So we assume that if direction going to upward, it is positive. So total of Fy direction is equals to 0. So we see they have 10 kilonewtons going to down. So it's opposite to what we assume. So it is negative values. And we continue we continue negative 10 times 4 minus FCD. FCD is going to down and is minus FFD times 5 over 30. 5 over 30, that means is cos. So from angle at the point F, the cos theta is equals to 5 over 30. That means adjacent over hypotenuse. So that this adjacent, so the adjacent is 5 and the hypotenuse is 30. So that's why we put 5 over 30. 5 over 30. So we substitute the the value of FCD that we got from this calculation to calculation that we do right now. It is a negative value, so negative 20. And we got force of FD is equals to negative 52 kilonewton, and it is a negative value, so that means it's compression. And we use moment formula at around the point C. So we assume the counterclockwise is positive, and sum of moment at around point C is equals to 0. So FCA is counterclockwise. So the perpendicular distance from FCA direction is 3.75 minus 10 times 3 minus 10 times 6 minus 10 times 9 equals to 0. So we got force CA is equals to 48 kilonewton, and it is a positive value. So we know that positive value is tensile force. We continue to next part. We use method of section at point I, G, H. Moment around the point I is equals to 0. So we got around the point I 10. 10 times 3, because the distance between G and I is 3, plus force G to H. G to H is going, it is a counterclockwise to I to point I. So equals to 0, and we got FDH is equals to negative 10 kilonewton, and it is compression. So we move to point G. We assume the counterclockwise is positive value, so moment around point G is equals to 0. We got FGE times 1.25 minus 10 times 3 is equals to 0. So we got FGE is equals to 24 kilonewton, and is a positive value. So that means it's a tension. So like I say early, they have two methods. The first one is method of section, and the second one is method of joint. So we focus at point I. By using method of joint, we focus at point I. We use the Fx formula and Fy formula. So we assume if the force going to right, it is positive values, and if the force going to left, it is negative values. And it happens at the horizontal force, and the total of Fx direction is equal to 0. So we see at the free body diagram at point I, force I to G is going to left side. So that means it's negative. And also point at FIH is going to negative. So that's why it's minus, it's negative values. So we times 12 to 12 over 30 because it is a sine theta. So that means sine theta equals to 12 over 30. So we continue, it is equals to 0, and we substitute the FIH values. We hold this equation and move to the next formula. That it is a sum of Fy direction. We assume that if force going to upward, it is positive. So what we got from the point I is negative 10 times 2 minus FGH minus FIH times 5 over 30. It is equals to 0. So that's mean we substitute the FGH values. FGH is negative 10 kilonewton. So we substitute this to this equation, and finally we got force at I to H is negative 26 kilonewton. It is negative value, so it's compression. And these FIH values that we got we substitute these values to this equation. So FIH is equals to negative 26. And then we got force at I to G is equals to 24 kilonewton. It is positive value, so that means it's tension. So we move to next part. We use the method of section at point I, A, D. We focus at 3 point. So we assume the counterclockwise is positive. The sum of moment around point I is equals to 0. So 10 times 3 plus 10 times 6 plus 10 times 9 plus 10 times 12 times FAB. FAB is going to, FAB is 12. So we got false FAB is equals to negative 25 kilonewton and it's negative value. So that means it's compression. And we use another formula that F that sum of Fy direction, we assume if force going to upward is positive. So negative 10 around negative 10 times 4, because from this FBD, from this free body diagram, we got 4 10 kilonewton going to down. So that's why it's positive, is minus, and we times 4. And minus FAB. FAB is going to down. So that's why it's negative. And minus FDB. FDB, like we know from the previous FBD, point D at the same line. So if so 5/30, because point D is going to down at is going down to point B. So we using cos theta. Cos theta is equals to 5/30. And we continue. The values of FB is negative 25. We substitute to this equation, and we got FDB is equals to negative 30 kilonewton. And we know negative is compression. Okay, next part. We got FAC is equals to negative 48 kilonewton, and FAB is equals to negative 25 kilonewton. We got this from the previous calculation. So we just have to find the FAD. So that's mean we using Fy direction. We assume that if force going to up, it must be positive. So what we got? Negative FAB because it going to downward, minus FAD because we focus on Y direction and it's going to down. So so if from angle at the point A, use the vertical side. That's mean vertical side is cos from the angle at A. So that's why 12 plus 12/30 is equals to 0. So minus plus minus is positive. So after do this calculation, we got FAD is equals to 27.083 kilonewton. So it is a positive value. So that means it's tension. And we focus at point C. Point C, we draw the free body diagram at point C, and we use Fy direction. Fy direction means we assume that direction, if direction going to upward is positive values. So FCD minus FCD going to down, so it is minus 10 kilonewton, minus FCF going to down from angle at the point C, it is a cos theta. So that means cos theta is equals to 12/30 equals to 0. We got FCD from the previous calculation is negative 12 and negative 20. So that means minus plus minus is positive. So we after do this calculation, we got FCF is positive 10.833 kilonewton. So we got positive values. That means it's a tension. And at the last part, we focus at point E. So we draw free body diagram at point E. And we use the Fy direction. We assume if force going to upward is positive. So negative FEF, negative force EF going to down, so it is minus E negative values, minus 10 is also going to down, is also downward, so it is negative values. And FEH is negative values because from point E to H we have to E force downward. So that means we use the cos theta from the angle of point E. Cos theta is equals to 12/30. So we substitute the values of FEF that we got from the previous calculation. Negative plus negative is positive. And after this calculation, we got FEH is equals to 5.417 kilonewton and it's positive values. So that means it's tension. Okay. That's all from me, and I will pass to next member. Thank you.
Hi everyone, I'm Darshan Yuniswaran and my matrix number is B132410 619, and I'm from BMKV S22. So for today, we're going to discuss about the static assignment, which I am from Group 4. So I'm going to discuss about the set 4, and we're going to look more into the question 2. Determine the reactions at A, D, and E. So this is the diagram given, and they've given us the length and the weight of the pulley, and it's in Newton, so we don't have to convert it into Newton. Okay, so let's go for the solution. Okay, in these questions, we are going to use the principle of static equilibrium, which states the sum of all forces and moments must be zero, and we will systematically solve for these reactions. Okay, and first of all, we are going to see this equation, the moment equation. As we can see that EMA, and this thing is on clockwise. So we draw an arrow like this and put a positive here. So moment is equals to zero. So as we can see that for finding the reactions at A, we will summing moments about A. Okay, the moment will be like EMA equals to zero. Okay, first the external force of 800 is on, creates a distance of 4 on a clockwise moment. So apparently this will be the m weight 800 times 4 is equals to 3200 nm. There we can see that it's on a clockwise moment. Okay, and for the vertical directions at E, which is EY, it creates a counterclockwise moment at A. Counterclockwise means opposing the clockwise moment. Okay, the level arm is 1.5 meter. So we can create an equation like this: m ey equals to ey times by 1.5, and for the horizontal direction at E, which is Ex, there we can see that Mex is equals to Ex times 2. Why 2? Because the horizontal direction at Ex creates a clockwise moment at A with a level arm of 2 meter. Okay, and the moment equation I created is 3200 equals to Ey times 1.5 minus Ex times 2. Combining these three equations, I got a new equation that I label as 1. So now the we can see here horizontal force equilibrium. Okay, I'm gonna find the horizontal force equilibrium. The sum of all horizontal forces. Sum of all horizontal forces is equals to 0. Okay, and the horizontal direction at A should be 0, right? Equals to 0, right? So we can create the equation like this. Since no external horizontal forces act on the system, I could simply use the AX minus sum of EX equals to 0, which I create a new equation like this: AX equals to EX. Okay, for the vertical force equilibrium, okay, the upward directions are AY and EY, and the downward external force is 800. So the 800 force is going down, so we need to use a negative here. Okay, AY plus EY minus 800, the force here. So we can create another equation like this: AY equals to 800 minus EY. Okay, from the equation 1 here, and using the equation 3 here, I can simply sub in the EY here with this. Okay, you can see that 800 minus EY, which are these 3200 ex2 over 1.5. Okay, now I'm gonna simplify this. Apparently, I'm gonna get this. Okay, ay is equals to 1333.33 minus, I just divided these 2 and 1.5, sorry, 1.5, and I got the 1.33 ex, and I labeled it as equation 5. Okay, going back to the arm. Okay, now we're gonna use the equation 2 here. You can see equation 2 here. Okay, ex is equals to 3200 equals to, sorry, for finding ex 3200 equals to ey times with 1.5 and minus with ex times 2. Okay, so we're gonna sub the ey here, this ey, into this equation. Okay, so 3200 subbing by this ey, and we are gonna get this ex is equal to 0 Newton by solving this. Okay, after we get the ex is equals to 0, as you can see that ex here is equals to ax. So whatever the value of ex here is going to be the same as ax. Okay, so using this equation, we can get the value of ax. As you can see that ex is 0, so subbing this ex of, well, the value of 0 here, we can get the ax value here. Okay, and we're gonna use the ex here into another equation where to find the ey. Okay, so using this equation here, just subbing the ex value here to be 0. Okay, and you will get the value of ey 2133.33 Newton. Okay, settle for ex, ax, and ey. So now we're gonna find the ay value here. Okay, we can even take this value, but to make it easier, I'll took the third equation. Ay equals to 800 minus ey. So the value of ey here will be sub into ey here, and apparently we will get the answer of ay. The vertical force is negative 1333.33. So the force will be pointing downwards. Okay. So after we get the value of ax, ay, ex, ey, we can simply get the value of dx and dy. Okay. So as usual, efx equals to 0. The horizontal force, sum of horizontal force equals 0. Just sub the value of ax, ex, ds equals to 0. Okay. All the horizontal forces are here. So in the horizontal forces, there is no external forces. So we don't have to minus anything here. So just simply by subbing the value of ax0, ex0, we can get the value of dx is also 0. Okay, how to know the value is 0? How to reconfirm it? As we all know that the sum of all horizontal force is equal to 0. If you plus ax, ex, and dx equals to 0, we will get the value of 0 Newton. Okay, so for the value of dy, we're going to use the same formula. Okay, but here we're going to minus 800 here. Why? Because there was an external force pointing down. Okay, so as usual, ay plus ey plus dy minus 800 Newton equals to 0. As you can see here, I have sub all the value of ay, ey. Okay, and if you simplify this one, you will get the value of dy is equals to 0 Newton. Okay, so these are the answers.
So for the next question, question 2 asks for find the all forces at B, C, and F. First of all, we look back at the diagram. So we draw the FBD first. We draw the outline from the diagram. So we get this one and this one. So after that, we find we write all the forces that we need to find, so that we can easier to find the forces using the formula. After that, we need to find the theta using the formula given. So we use cos theta formula, the adjacent divided by h. So we use 3 and the hypotenuse is 3.61. We divide them and we get the theta, that 33.8 theta. So we find the moment at C to get the By forces. So based on the formula, MC equal to 0, F multiplied by D. So we use the forces given. We assume that anti-clockwise moment as positive. So we write the formula and calculate it, and we get By equal to negative 266.67 Newton. So here the answer we get is negative. So the answer is not the anti-clockwise but clockwise moment. After than that, we need to find the we find the C moment. So we use the formula C sin theta. So we put the number and calculate it, that we get C equal to 19174.445 Newton. Then we sub it into the formula. We sub it into the formula C sin theta, C sin 33.8. So we assume that right as positive. So Cx equal to 0, 1917.45 cos 33.8 equal to 1593.37 Newton. That's Cx. Then we find the Cy. Same, also use the same formula. So we get the answer 1066.67 Newton. Then we need to find the Bx forces, because we have find the By forces. Then we need the Bx forces also. So we use the moment of E. So we wrote down the formula, we sub it, and we get Bx equal to 800. Then we need also find the forces at F. So the forces at F is the pulley. So we sub it into the formula. We use Fy equal to 0. We assume that the two down as positive. Fy minus 800 equal to Fy equal to 800. Same also to Fx. We assume that go to the right is positive. So we get Fx as Fx equal to 800. So here the final answer. Bx equal to 800, By equal to negative 266.6.
So, here the question number 3 for set 4. The question states that, in using the bolt cutter shown, a worker applies two 300 Newton forces to the handles. Determine the magnitude of the forces exerted by the cutter on the bolt. Solution. So, as we can see, FBD cutter AB. Cutter AB represents the cutting blade of the bolt cutter, forces are acting at points A and B, which are critical pivot points. Bx horizontal reaction forces at B, By vertical reaction force at B, and F force exerted by the cutter on the ball at point E. So the summation of forces in the x direction, total Fx equals to 0. Since no horizontal forces act on this part, the horizontal reaction force Bx is 0. Then FBD1, moment about point A equals to 0. 96 mm By minus 24 mm F equal to 0. Then we got negative 24 mm F equal to negative 96 mm By. F equals to negative 96 divided by negative 24 By. F equals to F4 By. This is one equation. So we move to the FBD handle BC. Handle BC is connected to the bolt cutter mechanism. A 300 Newton force is applied at the end of the handle, creating a moment around point C. By vertical reaction force at B. Cy vertical reaction force at C. Equation of equilibrium, moment about point C is equal to 0. 12 mm By minus 448 mm times 300 Newton equals to 0. So we got By equal to 11,200 Newton. Solving this equation, we can substitute By into one equation. So we got F equal to 4 times 11,200 equals to 44,800 Newton, and we change to kilonewton, so we got 44.8 kilonewton. So this is the final answer. Thank you.